Hello everyone, this is Mr. Sullivan. I'm going to take you through the rational functions review. I've split this into 3 videos. The first video on simplifying rational expressions, and I use that as an umbrella term for adding, subtracting, multiplying, and dividing. The second video will be on solving rational equations, and then finally the third video will be on graphing rational functions. Before you jump in, make sure you go and take a look at the previous 2 sheets, which give you the notes on how to, hints and tips on each of those aspects. So you want to make sure you review those, and then we'll jump right in. So let's start with number 1. First thing you want to do, obviously, is to take a look at the problem and identify what type of problem you're working on. And we can see here that we are adding rational expressions. So the idea behind adding rational expressions, we want to make sure we factor all our denominators so that we can identify an LCD, a least common denominator. I also notice on this particular example that we see a 2 minus x, and you guys should be getting used to seeing these sort of factors, and I'm going to say sort of where they're written backwards. We'd much prefer that to be an x minus 2 rather than a 2 minus x. So what I'm going to do is I'm going to factor out a -1, and so I'll write that as -1 times x minus 2. Okay, the right-hand fraction I can factor as x plus 2 times x minus 2. Now, you've got a couple different options in terms of what you can do with that -1 that we factored out of the x minus 2. Some people like to remove it from the denominator, put it up in the numerator. Some people like to put it in the middle of the fraction. I'm going to go ahead in this case and leave it in the denominator, and so therefore our LCD is going to need to have a -1, an x minus 2, and an x plus 2. Okay, so that will be my LCD. So I'm going to take a look at each fraction, identify what is missing in their denominators as compared to my LCD, and go ahead and multiply that fraction by the missing value. So the left-hand fraction, it looks like we're missing an x plus 2, so I'll multiply top and bottom by x plus 2. In the right-hand fraction, it looks like we're missing the -1, so I'll multiply top and bottom by -1. Okay, now if you remember, now we're at this step, we're going to multiply through the numerators. So in the left-hand fraction, I'm going to multiply by foiling. So we'll get 3x squared. The outside terms will give us a plus 1x, and the inside terms will give us a plus 6x, so that's a plus 7x. And then last times last is plus 2, and this is all over my LCD. Okay, when I multiply through on the right-hand fraction, I'm going to get a -4x minus 3. I'm distributing that -1, and this is all over our LCD. So now that we've multiplied through, we can go ahead and combine like terms in the numerator. So it looks like I'll have a 3x squared plus 3x and a -1 all over my least common denominator, which is -1 times x plus 2 times x minus 2. Now, we should always take a peek and see if we can factor the numerator. There might be some further simplification that we can do, but in this case, we cannot factor the numerator. So this is my final answer. Now, I do want to make sure I go back and state any restrictions. So I'm going to look to my LCD, identify which values would make the denominator equal to 0. And so the restricted values are positive and -2. So I'll include that with my answer. Okay, jumping over to number 2, again, identify what type of problem we're dealing with. Here we have a division problem. So the idea with division problems, we want to factor everything we can. So numerator will be x plus 6 times x plus 5. Denominator will be common denominator of 12 times x minus 2 divided by x plus 6, x plus 2, and we'll have a common denominator, a greatest common factor of an 8, and we'll be left with x squared minus 4, which of course we'll factor as x plus 2 times x minus 2. So I took out the greatest common factor, and then I factored it as difference of squares. Now, at this point, I'm going to note any restricted values, so I know that x cannot equal 2, nor can x equal -2. Now I'm going to flip and multiply, so x plus 6 times x plus 5 over 12 times x minus 2. This is going to be times 8 times x plus 2 over x minus 2 times x plus 6 times x plus 2. And now this new denominator of x plus 6 times x plus 2 has introduced a new restricted value, which is negative 6. So now I've got all my restricted values. I can go ahead and begin canceling. I'm looking for entire factors that will cancel. So it looks like an x minus 2 and an x minus 2, an x plus 6 and an x plus 6, an x plus 2 and an x plus 2. And then finally the 8 and 12 could cancel. 4 goes into both of those. It goes into 8 twice and it goes into 12 3 times. So if I pick up everything that was not canceled, it looks like I'm going to have a 2 times x plus 5 over 3, with the understanding that x cannot take on a value of positive or negative 2 as well as 6. And there's my final answer. Let's jump down to number 3, which is now just a straight multiplication problem. So again, we can factor everything within the problem. Bring out an x. I'm going to take out a 3, and I'm left with x squared plus 2x minus 8 times x plus 4 times x minus 2, and that's over x plus 6. We just got to do a little more factoring on the left-hand denominator. 3 times x plus 4 times x minus 2, and that is times x plus 4 times x minus 2 over x plus 6, excuse me. I'm going to pause now and identify the restricted values. So x cannot take on a value of negative 4, positive 2, or negative 6. We'll go ahead and simplify everything that we can. The x plus 4 and the x plus 4, x minus 2 and x minus 2, and the x plus 6 and the x plus 6. And so we're left with x over 3, with the understanding that x cannot take on a value of negative 4, 2, or negative 6. Okay, let's jump over to the last one, which is a subtraction problem. And the factoring a little bit more difficult in this one. We should hopefully notice that in the denominator of that first fraction, we have the sum of 2 cubes. So we're going to factor that. And again, you might notice that you can factor the numerator, and typically we don't in addition and subtraction problems. So I'm not going to factor it here, but I will talk about that at the end. So the denominator factors is x plus 2 times x squared minus 2x plus 4, again, sum of cubes. And then we have minus the 1 over x squared minus 2x plus 4, and that can't be factored. So I can identify my LCD now. My LCD is going to include x plus 2 times x squared minus 2x plus 4. And my restrictions will be that x cannot equal negative 2. The x squared minus 2x plus 4, if I set that equal to 0 and solve, that would not yield real solutions, so they'd only be imaginary, so I don't have to worry about that in terms of restrictions. So now, in order to get an LCD, I need to multiply the right-hand fraction by the x plus 2 over x plus 2. And I'll multiply through, so I have 2x plus 4 over my LCD minus x plus 2 over my LCD. Now be careful with subtraction. We have to remember that when we combine these over the common denominator, we have to distribute the negative sign through. So that will give me 2x plus 4 minus x minus 2 over my LCD, which, if I simplify, gives me x plus 2 over x plus 2 times x squared minus 2x plus 4, which I can cancel out the x plus 2 and give me 1 over x squared minus 2x plus 4, with the understanding that x cannot take on a value of negative 2. I just want to go back real quick. Some of you might ask, hey, couldn't I have taken out a GCF of 2 and factor this as 2 times x plus 2, which would have allowed me to cancel out the x plus 2? Absolutely, that is something that you can do in this problem. You'll get to the same point, okay? Actually, that might be a little faster. That's not always the case. So if you can always take a peek to see if you factor the numerator and can cancel out something. But just remember that with an addition and subtraction, you can only cancel I guess vertically with each fraction. You wouldn't be able to cancel diagonally. So for example, if there was an x plus 2 in the right-hand fraction, you couldn't cancel that with this x plus 2. Okay, so just be careful there. I like to wait to the end. Okay, so now you're going to watch the second video on solving rational equations.